interpolation and the curve fitting. Important topic as well. Interpolation and curve fitting. Interpolation and curve fitting. Okay. So what does interpolation and curve fitting do? So as per our practice, let's develop some background. This topic, I mean, in which what we have to discuss in this topic. So process and solution is different thing, but first you know what you have to do there. So if someone asks you that you have to solve error method, or you have applied modified error, and you have applied RK method or any one of this method, you know the process. Okay, we have to do this thing. Students mostly focus on how to solve it, but they don't know when to apply these methods. So for alerts, modified alerts, the theme background was that when we have to solve initial value problem, a differential equation, so we apply those methods. Okay, so what does interpolation and curve fitting do, and what's the difference between these two as well? That's the important point as well. Okay, so it's a very simple idea. Interpolation, let me define the first this definition, and then we will focus. For interpolation, interpolation is a technique used to find or read between the given data set. What does this mean? Read between is much better word rather than finding in a given data set. What we have to do, for example, string. Let's say you have performed certain experiment and the following data is given to you with respect to the time. Okay, time, and let's say there is a column. You are discussing the strength of a certain material, and you need to find the you are dealing with the stress or something. So you start compressing certain, like a pipe or some device, anything in your mind. So the following data is generated, which shows that how much the pressure or stress that pipe or a device or anything can handle. So at time t, you start compressing. Then at time or any other data, let's say 2 seconds, you note something, and then 4 seconds you note something, and let's say 6 seconds you note something. So you have the following data. Let's say the strength of any subject. So 20, 30 Pascal pressure that they are handling, 35, 40, for example. Okay, so you are performing sometime. Let's say there is a some setup of a pipe for the time being. No, that's not a right way to draw it. I think so. Assume that there is some. I'm just making the problem relatable. Okay, so let's assume there is some hydraulic press which has a cylinder inside. These are the inlets, and there is a fuel cylinder inside, and there is a fluid inside. Okay, so what I'm doing, and there is a rubber seal, and there is a piston that can move up and down based on the fluid. So there is a fluid inject inside and taken out, so this will move upward and downward. So there is some device that can move inside and outside on the piston. So this is just a piston that given to you. What we are doing, there is a metallic rod there, just hanging on a pivots somewhere. And what we are doing, we are allowing the fluid to flow inside so that this rod will be moved downward. Obviously it will touch that rod here, and then it will start applying the pressure on this rod, so it will start bending. Okay, so tensile strength, we call it material strength. So what will happen after a certain time, it will bend like this one, something like that, just for understanding, not to the scale. It will bend, and it will continue to bend, or maybe it will break down. So what you are doing, there is some sensor that, or some devices, based on the bending you are computing certain strength, that how much resistance it is providing over this pressure. Suddenly it will break down as well, but let's say this is the tensile strength that you have computed. I'm calling it a strength. So what we did, when you are zero, that is the uh, is a strength that you just started the experiment, like when the nozzle just touch this drive, this quantity. So maybe the data is not maybe decreasing, but let's say the strength is defined like that. So you continue to press it, it will bend like that, and after that it will break down. So there will be a zero reading, so we are not counting them. Okay, so this is the data has been generated in an Excel sheet. Now you are required to know you what you have now. You said after 0 second we have a strength this one, at 2 seconds the strength of the metallic rod is this one, and 4 the metallic rod is this one, and 6 seconds, after 6 seconds from the start of the experiment there is a fourth, and maybe after that it will break down process. Now if someone asks you that, okay, that's okay, but you have forgot to know the strength at t equal to 3 seconds. I need a strength at t equal to 3 seconds. So the problem is that the data that we have, it does not say anything about 3 equal to t equal to 3 seconds. It says something about t equal to 2 seconds and 4 seconds, and no information is available in between. Okay, so if we try to do something, some strategy, whatever be the strategy, so that we try to read between the data sets. That is our requirement is now, let's say if 3 seconds is there, so can I read the strength from this data? The other way is to perform the experiment again and note down the reading at 3 seconds of a same metallic piece of rod, but that will be a costly. So can we do something else? So yes, we can do one thing. We have this. We can do something like we can ask them how to find the missing value there. Okay, what is the missing value? There is no information derivative given. Maybe someone student is thinking I have discussed the same problem earlier as well. So no, we cannot solve it like that because derivative information is not given to us. So strength is this, and the t equal to 3, and then they are asking the missing one. So this is the data which is missing here. So if I apply any technique to read between the data set, that technique is come under the heading called interpolation. So what you are performing here is interpolation when you are trying to read the data. Keep in mind that interpolation only holds when you read between the data sets. Okay. Sometimes what we do, we use this data and try to predict the data outside the data set. For example, if someone asks the same question, okay, you have a reading at 0, 2, 4, and 6. Can you predict the reading at 8 seconds as well? So yes, you can do that. But when you do this thing, that is you are trying to predict or read the data outside the data set, then you are not performing interpolation, you are performing extrapolation. Okay, extrapolation is a different thing and interpolation is different thing. Extrapolation leads to a prediction type behavior, and interpolation is just to analyzing the trend of the data and predict the value in between them. Okay, so if you finding the missing value inside the data set, so you are dealing with the interpolation. Okay, now what is the curve fitting? There is no definition for it. Basically, curve fitting is a technique or a tool that helps you to perform the interpolation. Okay, so interpolation is just a technique that, okay, there is no fixed technique, there is a techniques that you can apply to find a missing value. But out of those techniques, there is one technique as well that is called curve fitting. What you do, from the name you can understand that we will try to replace our data by a function. So we call it curve fit. We fit the curve on it, and then if I know the function, then I will put t equal to 3 there, so that I can know the strength. So for example, if the strength is represented by s variable, then if you know the formula like that, strength depending on time is given by certain formula. So what you can do, you just need to put 3 seconds there so that you will know the strength. So curve fitting is just a technique or tool that used to represent data by a function by fitting a data on it, by fitting a function on it. Okay. So interpolation is what? Interpolation is just a technique, some mathematical technique, so that we can read the missing data. If data is missing, then how to read that data. So sometimes these are very useful strategies. So we have to discuss few formulas there. In this topic, I will also develop some open-ended problem as well, because we have to grade the student based on apart from the assignment, open-ended problem as well. So one of the topic which I will explain to you in a later stage, and maybe in the next class, that has to be open-ended. What you have to do, you have to go through that topic, completely learn that topic, and solve the problem based on it. This all, in short, this is simply one. From interpolation, I will select only one topic that you have to go for your own on your own. Like you have to do it all your own. That is, you have to learn it, solve it, and bring the answers to it. Just open ended. You can solve it as long as you want. Okay, but you have to submit it. So that's what, in our case, this is the open ended problem idea. So self-learning is the main objective, and problem solving is the main objective of the open-ended problems by your own, like not taking the help from each other. Okay, so interpolation is also a technique used to find a or a read. Find means this value, or read between the data is when you have to find something to read the data. Okay, this is how we have defined. So this is basically the for today's lecture. What we have discussed is a background. In the next class, I will upload. I will continue to discuss the interpolation formulation. We have to discuss Lagrange interpolation formula. Let me write down this for you. Topics that we have to cover is Lagrange interpolation, and I'm writing those topics that I have to cover. Okay. The other topic, one of this topic, which will be an open-ended problem, is given to you. Lagrange interpolation, Newton's interpolation formulas, Newton's interpolation. Okay, these are for interpolation, and the third topic is curve fitting. Curve fitting, linear and non-linear. This is what I will give you the framework in next lecture. Okay, there are the formulas that I will show you, and I will let you know how to use. And this is some derivation involved in it. I hope that in next class I will cover this thing in a recorded lecture of 2 hours, and then we will solve the problem.